We're back with video number 3. So we need to write the equation of the line tangent to f of x equals 4x squared minus 5x plus 2 when x is equal to 1. The AP Calculus test writers love questions like this. They want you to write the equation of tangent lines. Okay, so first we need the equation of a line. Now if I asked you to give me a formula for the equation of a line, I'm guessing right away in your heads you're thinking y equals mx plus b, which is a fantastic form of an equation. In fact, that's slope-intercept form, and we call it that because we've got a slope and a y-intercept. The problem with this is that it's really good for graphing, but it's not the greatest equation for writing. If we want to write an equation, we want to go to the sister of this function, and you may remember this one as well. Y minus y1 equals m times x minus x1. That is our key equation that we're going to use. Okay, because this, if you recall, is point slope form. Because we need a point, x1 and y1, and we need a slope, m. What makes this equation better than slope-intercept form for writing is that this equation will accept any point, whereas this equation will only take the y-intercept. So here's our key, using point slope form. Once we realize that we just need point slope form, it's a matter of plugging in values. Now, we're going to plug in values for x1, y1, and m. We do not plug in values for y and x because when we're writing an equation of a line, that line's going to have y and or x in the equation. We do have to plug in for the other 3 values. Well, the x1 is nice. That was given to us. So the x1 will always be the given x value. Now sometimes they'll give you the y value as well. Sometimes they won't. If they give you the y value, for example, if they gave you the point 1, comma 1, well, then we would put that given y value in right away right here. But if they don't give you the point 1, 1, you can easily find it. How do you get a y value of a function in general? That's right. You plug the given x value in. So we're going to plug in the given x value. That is to say that y1 is the function's value at x1. Okay, so let's go to our function. We have f of x is 4x squared minus 5x plus 2. To get y1, we need to plug the given x value into the function. What happens when we plug 1 into the function? That's right. We'll have 4 times 1, technically squared, but we don't really need that for 1, minus 5 times 1 plus 2. So that's equal to 4 minus 5 plus 2, or 1. So now we have our x1. We found our y1, there's our y1 right there, and we need, finally, our slope. We need the slope of the tangent to a curve at a point, which the song tells us is, yes, the derivative. So we now need f prime of x. If we get f prime of x, that's our derivative, and the derivative is the slope of the tangent to the curve at a point along the way. Hey! So here we go. Derivative of f of x. Take a second and find that now. All right, I'm guessing that you wrote down 8x minus 5. That's a good derivative. We're interested in the value of the derivative at the given x. Well, the given x is 1, so if we find f prime of 1, that is our slope. The derivative is the slope of the tangent line. Well, this is our derivative. We plug in the point. We have 8 times 1 minus 5. You all know that better as 3. So our m is 3. Now we get to put everything together. So we go back to our form. We have y minus the given, the value of y1, which we found to be 1. So y minus 1 equals m, which is 3. And then in parentheses, x minus x1. X minus and the x1 value is also 1. And this box right here is the equation of our line. Now, it's not written in slope-intercept form, but we don't have to write it in slope-intercept form. Our charge was to write the equation. This is an equation. So we're done.